Hello everyone, welcome to the channel. Today we'll be doing questions based on domain and range of a function. So let's begin with the most basic one, that is a linear function. So we have taken x minus 2. Now, the domain of any given linear function is real numbers and the range is also real numbers. Now, how do we decide what is a domain? The domain is decided on the basis of what values of x are allowed in here. Which values of x will make the function defined. So you take any real number, this function will exist. You have to think of a real number or its subset. So over here, all real numbers are fine with us. So we take the domain as R, and to find the range, we can take it as equal to y, that is our image. And let's find what is x. Now for every real number x, what kind of values are allowed here? You take any real number plus 2 will also be a real number. So you can take any value for y or any real number for y. So that is how we decide about what is the value of x will define what's the domain, and the value of y will define what is the range. Now for a linear function, it's quite simple. You just have to take both of them as real numbers because any real number will satisfy this function. Now let's consider another example. Let us take gx as 1 upon x minus 2. So we see that if the denominator is non-zero, this function is defined. So that means x should not be equal to 2. We are discussing about the pre-image value x, and so the domain is all real numbers except 2. Okay. Can also be written as minus infinity to 2 union 2 to infinity. This excludes 2 from all real numbers. To discuss about the range, let us equate to y and find x. So taking reciprocal on both the side, and if you take LCM, so once again, if the denominator is non-zero, this will be defined, so y should not be equal to 0, and so the range will be all real numbers except 0. So now taking root of x minus 2. Now we know that we do not want a negative value within the root. It should be non-negative. So we are taking x minus 2 greater than or equal to 0. That makes x to be greater than or equal to 2. So the domain is going to begin from 2, or it is to infinity, including 2. Now to get the value of y or the range, let's equate fx to y, that is root of x minus 2 to y. What is x minus 2? Y square, and x is y square plus 2. So we observe that what kind of values of y are allowed here? All values are allowed. And from here, we know that y should be greater than or equal to 0. So whatever non-negative value you take, it is going to define x, and that is why the range is 0 to infinity. Because from here we already knew that it is positive root. So 0 to infinity. So now we have a similar one, 1 upon root. So when it comes as denominator, now we want the value only to be greater than 0. First of all, it is under root, so it should be non-negative. Then it is in the denominator, so it cannot be equal to 0, so it has to be positive. This value has to be positive. So x is greater than 2, and so the domain is going to begin from 2 to infinity and not including 2. So from here, we have also decided that this gx value is going to be greater than 0. So to find the image, let us equate to y, wherein we also know that y is greater than 0. So let's take reciprocal on both the side, squaring both sides, and so x is So we see that if y is going to be greater than 0, then it is going to be defined for all, it is going to define all values of x. And so our range is 0 to infinity. All positive real numbers. This kind of questions can also be done by finding out when is this value 0, that is for 2, which is the critical point. Mark it on the number line and look for values bigger than 2. So if you take any number greater than 2, say 3, so you see this is positive, and take any number smaller than 2, say 0, 0 minus 2, which is negative. So we observe that only values greater than 2 will define this, that is the term within the square root will be positive. So that is also how you can define the domain, that is 2 to infinity. Okay. For the range you can follow the same. So let's take a quadratic function now. It is x squared plus 5, and for this, since it is in the numerator, any value of x will define the function, because there is no square root term, it is not 1 upon. So whatever value of x you take, it is going to define the function, or the domain is real numbers. In order to find the range, we will have to equate it to y, the fx value to y. So we have x square is y minus 5, and what is x? Root of y minus 5, obviously positive or negative, any root will do. Now since we got square root, now we have to think that which values of y are allowed in here. You can put it as a critical point, as we discussed in the earlier question, that y minus 5 is 0. So what is y? 5. So the critical point is 5. Take a value bigger than 5, or since it is y minus, the right side will be positive and the left side will be negative. So value greater than or equal to 5 will do for us, and the range becomes 5 to infinity. And if you do it in another way, like the square root term should be non-negative, and you get y greater than or equal to 5. So 5 infinity. So 5 infinity is the range. So now we are taking 1 upon x square plus 5. The denominator should not be 0. So let's equate this. Alright, not equal to 0. So x square is not equal to minus 5. And this is true for every real number, and hence the domain is real numbers. There is no such value of x which will make this function undefined. Now going to the range, let's equate gx, that is 1 upon x square plus 5 to y, and we are looking for finding x. So let's find x, taking reciprocal, put 5 on the other side, and what is x? Okay, let's take x square first, and now write x, 1 minus 5y LCM, and now the square root. Now we have two values. So it's better that we go with the critical point method. And from here we have y is 1 by 5. These are the two critical points. So let's put this on the number line and find which one is positive and which part is negative. So taking any value bigger than 1 by 5, let's take 1. So put 1 in here, 1 minus 5y, which is minus 4, which is negative, and y equal to 1. So we are putting 1 in both of this, and we find this is negative numerator and denominator is positive, so this is going to be minus. So this is going to be minus, then positive and negative. It's going to follow in this manner. You may take any value in between and check. So now, and you can also see, if you want to do it directly, you can do it in this way. If you do not have the variable first for negative factors like 1 minus 5y it is. If it was 1 plus 5y, it would not matter. But if you do not have the variable first, then it's going to start with minus plus minus. If it would be 5y minus 1, it would be plus minus plus. In this order it would follow. Okay, so over here we have this value to be positive and we are interested in only positive value because it is square root, and that is why the range turns out to be 0 to 1 by 5, and 0 is not allowed since y goes in the denominator. So 0 to 1 by 5, open interval. Okay, you have to check in such kind of questions, whichever factor or from this factor, whatever the critical point you get, that it will not come in the range. Otherwise, upon 0 it would become, and that would make x undefined. So once again, it is quadratic, but it is a rational function. We have to check for both, and x square is fine. You can take any real number for x square, so numerator is not any problem. For denominator, let us see that it shouldn't be 0, so x square should not be equal to minus 1. And that is true for all real numbers. That means the domain turns out to be R. But for the range, let us equate this to y and find out x. So taking 1 plus x square on the other side, y plus yx square, and we need to find x, so bring all x terms on one side, x square common, so once again, like the previous question, we have two factors. The critical point for numerator is 0 and for denominator is 1. Remember, 1 will not be allowed in the range because otherwise 1 minus y will become 0. So we want this not equal to 0. So y is not equal to 1. So put this on the number line, 0 and 1. Once again, it is not y minus 1, it is 1 minus y. So start with minus, plus, minus. Square root value should be positive, so it's going to be 0, 1. Cannot be equal to 1, so it is closed open interval 0, 1. 1 upon 4 minus x square can be factorized, so let us factorize it. It is not under root, so it's only the denominator should be non-zero. So 2 minus x should not be equal to 0 and 2 plus x should not be equal to 0. X not equal to 2 and minus 2. These two values from all real numbers are not allowed, so domain becomes real number minus, remove these two numbers, same the real number minus 2 comma 2. And for the range, let's once again equate it to y equal to y. So taking reciprocal on both sides, we are looking to find x equal to, so 4 minus 1 upon y is x square, and let's take LCM. So what is the value of x? Plus minus 4y minus 1 upon y. Again, two factors, critical points. Let's put it on the number line. One is y and another is, one is y equal to 0, another is y is equal to 1 by 4. Now this time we have the variable first, so start with plus, minus, plus. So all the positive values will do for us, and the range turns out to be, all the positive values means we are discussing about this, minus infinity to, okay, first check which values will not do from this 0 and 1/4, because we have to look at the extreme values. So since the denominator is y not equal to 0, 0 is not allowed. 1 by 4 is okay with us. So that is the range. Now, first what we did, we decided, okay, what are the critical points? After deciding the critical points, we saw in this 3 subintervals which we got of real numbers, which one is positive. because in square root only positive values will be allowed. So we got this as the positive value. Once we did that, we have to see out of the two extreme values over here, the two critical points which we got, which one is not allowed. Like the denominator you have to check. The denominator was going to be 0 for 0, so don't take 0 in the range. Now we have taken a modulus function. Modulus function is one of the most common function that we have. Its domain is real numbers here because it is in the numerator. We do not have to think when it's going to become 0. Even if it becomes 0, it's fine with us. For the range, you see that all numbers are going to become non-negative. So the range is going to be 0 to infinity. We will not get negative values. Okay, so that's fine. If it was 1 upon, then we would have to think. Suppose fx is 1 upon modulus x plus 2. Now in this case, the denominator cannot be 0. So x is not equal to minus 2. And so the domain is all real numbers except 2. We don't want 2 there. And for the range, all the numbers are going to become non-negative, but because we are not going to get x plus 2 equal to 0 also, so the range is going to be open interval 0 infinity. See the difference over here, because all real numbers were allowed, you could get 0 as your answer. Over here, denominator term is there which cannot be 0. So in the range, you are never going to get 0. 0 to infinity. Any value bigger than 0 will be possible. So it is algebra of modulus x plus 2, that is one function, and denominator is having a linear function. So first, when we notice the numerator, because there is no square root, only under root terms, we'll have to decide for numerator whether what real numbers are allowed. So for here, all real numbers are allowed, but for the denominator, we notice that it should not be 0, and so minus 2 is not allowed. The domain becomes all real number except minus 2. Now for the range, if we notice, since the function is modulus x plus 2, and if we remove the modulus sign, we would write plus minus. So for positive numbers, it's going to remain positive, and for negative numbers, it is going to become minus of minus, turns out to be positive again. And so we can write plus minus. X plus 2 will get cancelled, and the answer will be either plus 1 or minus 1. So the range is only plus minus 1, either plus 1 or minus 1. Only this much. Now for this part, if you want to understand it in another way, you can say that for modulus, the critical point, this was, I'm talking about the numerator, the critical point is minus 2. So we have the number line in two parts, minus 2 to infinity and minus infinity to minus 2. If you take a value bigger than minus 2, let's take 0, then modulus x plus 2 will be 0 plus 2. I'm going to write it as x plus 2, so it is positive. But if we take a value smaller than minus 2, and if you want to make it positive, you will have to put one more negative sign. See, I'm not writing modulus, so I'm thinking about taking plus and minus. So I'm taking minus 3, and minus of minus 1 will become 1. So in order to make value smaller than minus 2 also positive, you have to take minus of x plus 2. That's how modulus function is defined. So over here, the range is minus 1, 1. So we have taken few functions. These were some of the basic functions where we could find the domain and the range. More questions on finding domain and range we'll take up in the next video. So do like and share the video, and of course subscribe to the channel. Thank you.